Hi, I'm doing Paul McWhorter's Arduino Uno R4 Wi-Fi lessons, and we're up to lesson number 7, when he wants us to demonstrate that we do actually understand how to do maths in binary. But before I get on to that, I just want to show you a couple of things that you might find useful. And the reason I have to do it first is because I'm trying not to use too much paper, so I want my whiteboard, and I've written all the notes for this video on my whiteboard. So I'm going to do this first, then I can wipe out everything and do it. Right, the first thing is, if for example you're following along with one of his lessons, and there you go, and you're watching the video, and as you're watching it, you're wanting to type in. And he's saying, right, you want to set the pin mode to that, and he's doing it faster than you can type. So while it will be playing like that,
3, 4,
and you have your
5,
Arduino.
6,
okay, so he isn't
7,
have to do
8,
to type in.
9.
But
Don't say
typing.
10.
You're
Okay,
typing,
what do we
going,
have to understand? And to understand binary, you have to understand what you're really doing in decimal. What
so
has just happened?
Stop, Paul.
We've used
pause, and then you think, oh, I've got to get my window back. So then you have to get back there, and you type in. You finish typing in, you've caught up, and then you want to do that,
all 9
and you've
of our
lost your
characters.
window
We
again,
can't go
and you
to
think,
another
oh,
character.
This is really annoying. So I've realised that there's a better way of doing this. If you double right click on the video window in YouTube, there's this menu that I've never seen before. So if you go picture in picture, there you have it. You have a nice little copy of the window. And you can minimize the browser window, and you have this, and it will, you can move it around, you can make it bigger, and it retains its ratio of height to whatever. That's the smallest it can be, that's the biggest it can be. So you can just put it where it's always on top, so you can put it where you want, and you can play.
So the way you have to look at this,
and pause, and it means that you aren't perpetually losing what you're looking at. And once you've finished with it, you can't rewind, but you can go back to the tab, and then you can take it back a bit, and then you can go back to picture in picture, and then it will be, sorry, my internet's very slow, it will get you back to where you were. And once you've finished with it, you can just do that. Now also, when you're making a video, you might want to say, yeah, I've explained all this last week. And what you can do is you can say, go to my video for lesson number 5, or you can say, see the link below for the explanation, or you can just say, go and see it. Or you can actually, before you start recording your video for the lesson, you can go in there and go onto your own video, and you can say, all right, I want to play from there. Then do your double right click, picture in picture, minimize that, you can move that to where you want, and then when you get to the point of your video where you're saying, I've explained this all before, you can go watch this, you can press play into an array, enough of the that setup, stupid woman. And then when you're finished, you can say, yep, that's what I meant. You could close it, and you can get on with your lesson. Now I think that's pretty jolly good myself. So now I've got something else that I'd like to show you, but instead of YouTube, this is the Arduino IDE. If you're that little program fits on the screen perfectly. But if, for example, you made your void setup a lot bigger, and you'd finished doing your void setup and you now want to do your void loop, and you keep saying, oh, I can't remember what my variables are called, so you have to keep going up to look at them, and then down, and then up. What you can do is, if you go to that left, the left-hand column before the void setup, you can minimize it so it compresses it all. It tells you that you do have a void setup, but it doesn't tell you what's in it. And you can do that for any of them. So I just thought that would be quite fun. I will get rid of that. For good measure, I'll get rid of that. Now, another thing, when I first started playing with the Arduino, there were two annoying things. One was, when you have a program like, oh, it doesn't matter, whatever it is, lesson 2, for example, you have your folder for lesson 2, and within that you've got your Arduino sketch for lesson 2. And I thought, that's pretty stupid, why do you need both of those? And I thought, either it's something that you can get round, or there's a reason for it. And also, in Thonny, if you want to open another program, you can go File, Open, and it will create you another tab. So it means that you can compare your two programs. You can copy one chunk from one program to another. But in the Arduino IDE, it doesn't. If you go File, Open, just anything, open that one, and it opens in another window, and you think, I didn't actually want that to happen. But equally, you think there must be a good reason for that, so we'll close that. So if you look here, I hadn't noticed this, you've got new tab, rename, delete, previous tab, next tab, whatever. So if you do new tab, name for new file, cat. Okay, now you've got two tabs. You've got that and you've got that, which has nothing in. And what you can do is, if you want to split up, if you've got a massively long program, you'd prefer to split it up into manageable bits. So you can, for example, take that bit and shove it into there. So now you've got your void set up in one file and your rest of the program without the void setup. And you can do it again. You could go new tab, call it dog. Okay, go back into that, and you can grab all of the void loop if you wish. X. Stick it in there. So you look at that, you think, well, how can that possibly work if I try and compile it? And equally, all of those are pretty useless. But if you compile it, I will just plug this in to make you see what I'm getting at. If you plug it in and you compile, there, it's still working. Because what, yes, it's still working now. It took a while to upload. Now, what it does is it takes all the contents of that file and then it concatenates that and that, and it works. So I don't know whether that's a good thing or not. It's kind of, I think possibly that is actually a class, but it doesn't tell you that. It doesn't matter. And you always put that always is on the left, and then all the other files are in alphabetical order. So if you, for example, rename dog, you rename it Ant. Okay, that's odd. That's very odd. I really did think that it would, maybe the next time you open it, it will move it, because normally they're in alphabetical order. So that didn't go well then, did it? Now, if you do an open and you go down to where your program is, which is that one, I think. There, inside that file, you've got ant, cat, and your original program name. So we'll cancel that, and you can, I haven't tried this, rename that to, ooh, this might be a bit dodgy. I will see what I can new name. Let's see what that does. If you save that, it's thinking about it. It's still thinking about it. I'm going to stop that. Right. Now, it's actually arranged them in the right order now. So there you have your lesson 5, blah, 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 new name, and whatever. And if you do an open, sorry, go down there. It has renamed it. It's renamed the folder name, and then it's renamed that in there. Now I think that's pretty jolly good, and I don't know if anyone will find it useful, but now I can rub out everything on my whiteboard, and I'll be back to show you my proper homework. Right, this is the real homework. So we're wanting to multiply that number by that number in binary. So we'll first start writing it down. 1001 times 1011. Draw a line under it. Now if you're multiplying by 1, you just write the number. So you go 1001. You move along 1, so you put a 0, and you just write the number again, 1001. Now, third one, multiplying by 0, so you needn't put anything. So fourth one, you put 3 zeros. 1001. Now you add them all up. 1, 1, 0, 0, carry 1, 0, carry 1, 1, 1. Now that comes to 1 plus 2, 4, 8, 16 plus 32 plus 64 equals 99. Right, now that is 1, 2, 4, 8, so it's 9 times 1, 3, 11. And 9 times 11 equals 99, which is lucky. Now, this is the difficult bit. We will try and see whether we can go backwards. So, if I write down the number we got, which was 1100, that helps. 110011, and you divide that by we'll divide it by the bigger one, 1011. Now you say, will it go into that? No. I'll put the leading zeros. Will it go into that? No. Will it go into that? No. Will it go into that? Yes, it will. So you write 1011 there. It goes in once, so you write the 1. 0 minus 1, too difficult. You've got to borrow. Right, you've got to borrow again. So you cross out that. Then you've got 2 there, but you need to borrow. So you cross out that, put a 1, and you've got 2 there. So 2 minus 1 is 1. 1 minus 1 is 0. 0 minus 0 is 0. 1 minus 1 is 0. Okay, then. You've got to bring down another digit. So you bring down the 0, and you put a 0 there. You still need to bring down another digit, so it's a 1, and you put a 0 there. You bring down another digit, and that's big enough. In fact, it's the same size, so you go 1, 0, 0, 1, doink, hurrah, 1. So there we have it. 99 divided by 11 is 9. Well, that was lucky.